Deck bridge, clear to go.
Clear to go. Coming up, guys. Okay, you can clear, Mark. Okay, tax off. Okay, that's it. Lander away.
Roger, lander away.
So I thought we'd run through the landers kind of briefly and give you an idea of actually what's on them and some of the data that we're collecting from the instruments that are on them. But essentially what a lander is this. This white stuff that you see up here is actually foam. It's called syntactic foam, and that makes the entire system positively buoyant. So as we're looking at it at the moment, it's positively buoyant, and we make it negatively buoyant by putting these weights, these big steel weights, down in the center of the lander, and we strap that in. Now, the basic idea of a lander is that we make it negatively buoyant with that steel, we send it to the bottom of the ocean, it records for a period of time which we can define, and then when we want it to come home, we release that steel weight which remains on the seafloor. The lander becomes positively buoyant and then it floats to the surface. So that's essentially how a lander works. The type of equipment that we've got on the actual lander, the thing that I'm most interested in from an ecology perspective are our cameras. So this is one of our cameras down here. It's a full HD camera, records at 30 frames per second, and that's our main camera. And what that's filming is the bait, which will be presented about 1 metre in front of the lander itself on this arm. So this arm pulls out, it's tucked in at the moment, and then we have a large mackerel that sits on the front of the bait arm there, and we essentially soak the lander. The operations take about 12 hours, but we're looking from anywhere from 6 to 10 hours on the seafloor for that soak. Up the top here is a light. So we just have one light for each of the landers. Obviously it's really dark at 5,000, 6,000, 10,000 metres, so we need to bring our own light source with us. Sometimes we also have a second camera. There's only one on this one at the moment, but we often have another camera on the end of the bait arm, and we use that camera to get really nice close shots of the organisms that we're filming. We also have a different position on Cranch over there. We have a camera up the top, and that's really for our geologists to get a bit of a wider view of the seafloor to understand a bit more about the substrate and some of the geomorphology that's going on. So these landers are powered by 3 batteries. Each battery is 24 volts. They're essentially like a car battery really, but they're submerged in oil, which we'll get to later on. 2 of the batteries are married up together to make 48 volts, and those 48 volts run our modem, they run our light, and they run our communication side of things. And then one of our batteries at 24 volts runs our CTD and our camera. So it's a pretty complete power system. That's enough to get a decent 12-hour soak out of the landers. Ideally, we want a 24-hour charge on them. And again, it's just like a normal car battery charger. One of the other sensors that we have that our oceanographer loves is this thing down here. That's our CTD, and it's a pump CTD. So essentially that's pumping through water and it's collecting 3 things: conductivity, or how salty the water is essentially, the temperature and the depth of the lander as well. And with that we can work out salinity and look at things like water bodies, and even on the descent, how the water changes through space to understand the different water bodies and currents and things like that. I'm not an oceanographer, but Jess can explain a little bit more about that. You'll also notice down at the bottom of the lander is a blue mesh trap. We're essentially trying to collect 3 different groups of organisms: fish, decapods or prawns mostly, and amphipods. At the moment we're not getting too many fish, but we are collecting lots of little amphipods. The amphipods that we're collecting at the moment are quite small, and they tend to come out of that trap down there. So we're also using other smaller funnel traps, which we position near the bait and at other locations around the lander as well. On this lander, we have this thing up here. It looks like it's got 2 little rubber gloves on the front of it there, but these are laser scales. So we know the distance between those lasers, and they're perfectly parallel to one another. They shine down just in front of the camera, and we can use those scales to get a good understanding of how big the animals are in the field of view. They're only rated to 6,000 metres, so we've only got one at the moment. We're just trialling those, but everything else on this lander and the other two are rated to what we call full ocean depth. So essentially they can go to the deepest parts of any of our oceans. A little bit more about some of the tech that we're looking at. There's obviously a lot going on in terms of cables and electricity and power at the moment. This thing here is really important. This is our modem. Essentially what this does is that it allows us to communicate with the lander from the ship. So this little black bit at the top, essentially we talk to it using acoustics. So we scream an acoustic signal from the ship, it screams an acoustic signal back, and we can understand the general distance from the ship to the lander itself. These ones are a little bit more complicated, so they can talk to one another. And the reason why they're a bit more complicated than some others going around is because we use them a lot in sub operations. So what will happen is we'll have 3 landers down in a triangle, and then we'll deploy the sub usually in the middle of that triangle, and we can get a better understanding of where the submersible is traveling between those 3 landers. One other little technical thing here is this little black box with the white stick coming out the front. So this is a compensation bottle. Essentially what's inside that bottle is a condom full of oil with a spring in the middle of it. And a lot of the electronics on these landers are filled with hydraulic oil. The reason we do that is because if they're filled with air, air compresses more under hydrostatic pressure. So if we get a bubble at the surface, or if we get a tube or a chamber, unless that chamber is really rigid, made out of titanium or something, it's going to collapse. But if we fill that chamber with oil, in this case hydraulic oil, it won't compress as much. In fact, it'll barely compress at all. So what that compensation bottle is doing is it's making sure that all the lines that are full of oil and all of the electronic boxes that are full of oil maintain a positive pressure. So even if you do get a little leak, hydraulic oil comes out and water doesn't come in. So that's a really important part of the lander electronics. This little mechanism down here is the thing that controls the release of the weight. So this cable gets threaded through one of the steel weights, and when the lander is ready to be deployed, ready to be jettisoned to the surface, this little link here, electricity passes through here and it dissolves that little burn wire. When that dissolves, this little latch here, spring loaded, will open up and it will drop the weight. So these things are really, really important. If that doesn't burn or if that doesn't go off, the lander doesn't come home. This burn link is controlled by this modem and this release. So that's one of the mechanisms that we use to deploy the weight and to jettison the lander to the surface. If we switch around to the other side, I'll show you one of the other releases. So this is the other release that we have on the other side of the lander. This is a timer bottle, and we use it as our primary release to deploy the weights. Essentially in there is a complicated countdown system. It's kind of like, I don't know, speed or a bomb. We set a timer, and when that timer gets to 0, it sends an electrical signal down to this release, same as what we have on the other side, and that's the primary release to dump the weights. Now we get up in the morning, or some of the other boys get up in the morning really early to make sure that it's actually released, and if it hasn't, something's gone wrong, and then we can go over to the other side and ping that and burn that other wire. So 2 mechanisms to deploy the weight, just in case things go pear-shaped. So on this side, we've got a couple more sensors. This little thing here is an RBR duet. That's measuring temperature and depth. So this is a secondary system to our CTD. And the idea behind this is that it samples at higher frequency. So as it's traveling through the water column, we get a better understanding of how the water properties are changing. This here is to help our oceanographer as well. This is what we call a Niskin bottle. This Niskin, it gets cocked. So it gets opened up on the deck. In between these 2 ends here, we put a galvanic release. So a galvanic release is essentially a zinc anode, and once that zinc anode is put in salt water, it starts dissolving. The ones that we have are timed at 4, 6 or 8 hours. So the bigger the anode, the longer it takes to burn through, but essentially after 6 hours, that pulls through and it collects water. Now that water sample is really, really important. What it does is it allows us to calibrate the water sample itself with the actual measurements that the CTD is recording to make sure that they're well aligned. When we start getting under high hydrostatic pressure or deep in the ocean, the sensors get a bit wonky. The pressure has impact on the sensors, and this little water sample is to make sure that they don't get too wonky. These three things up here help us to locate the lander when it comes to the surface. So obviously once it's dropped its weight, it takes a couple of hours to come to the surface, and we can do some calculations to work out precisely when it's going to reach the surface. And then we get up on the bridge of the ship with a pair of binoculars and we're looking for that big orange flag up there. If we can't find it, or if we're doing night operations, this thing here is a flasher, so that's a little flashing LED. The beacon in the middle is essentially an RF beacon, so we can get a directional finder out and it pings off radio waves and we can actually locate where it is. And then if everything's going super pear-shaped, this thing here is iridium with a GPS in it. So essentially that's a self-contained sat phone. When it reaches the surface, it'll ping a message to satellite, which sends a text message and an email to the bridge, and a few other people here on board, and it gives a lat and long of where the actual lander is. Now this thing's a bit slow, so only when things go really, really pear-shaped do we start looking for our iridium signals. One little piece, well it's actually not a little piece, it's a really important piece. You might be able to see, it's kind of hard to see in here at the moment, but that's our junction box. So that's, I guess, is the hub of the electronics. That is also oil filled as well. So we don't have to deal with really expensive housings. Obviously, our cameras, they're not full of oil, they're just full of air. And so the housings for those cameras are titanium and the outside is sapphire glass. Same with the RBRs, these are titanium as well. Obviously it's quite expensive, so we try to avoid using titanium, and it's really kind of just used for these smaller sensors. A lot of these things are manufactured on the ship itself, so there's a 3D printer on board, so there's nice carbon fibre 3D printed corners just to make sure we don't hurt ourselves. Roger, the fitter, if anything breaks, he can weld up a whole bunch of stuff on here, or provide us new clamps for any of the sensors or anything like that. But yeah, ultimately scientists, we love going back to the old cable ties and Velcro rope and hose clamps. So no matter how sophisticated the system is, there's always a cable tie on something to kind of bring it all together. I think night operations are my favourite because obviously you've got a really big LED light on there. The water out here in the middle of the Pacific and most areas where you're in really deep waters, quite a vivid blue, and so the visibility is incredible. This thing, as it starts to fall away, it starts sinking around 50 metres a minute, so it's not super quick, but yeah, you just see that light kind of pass off into the distance. Now we haven't done any night retrievals just yet, but it's really cool watching these things get brought to the ship and retrieving them at night. Obviously they pass out a really, really big blue glow, and when they're sitting on the surface for a little while, you get a lot of things attracted to them. So you see a lot of squid once it's up at the surface, and a lot of flying fish. I was looking from the footage last night, the deployments last night, we're getting a lot of flying fish just as they were being deployed. But yeah, really, really incredible kind of vision, particularly in this area where the water is just so clear. Operations, this ship is a well-oiled machine. There's 7 or 8 people in deployments, and they can knock each one of these off in about 15 or 20 minutes. Really, it's just the transit between the sites that takes the time. But yeah, that's essentially our lander. It does look really, really complicated, but when you boil things down, it's really just a bunch of foam, a steel weight, a battery, and a camera. We throw it over the side and call it back when we want it to come home.